everyone, my name is Joanna Keogh. I'm going to be talking to you today about intermittent hypoxia or low oxygen and our body's physiological response to this stimulus. Oxygen is vital for our survival, thus it is important that oxygen homeostasis is maintained. When exposed to hypoxia, humans experience a hypoxic ventilatory response, which is where ventilation increases to try and get more oxygen into the body. There is plasticity in our response to hypoxia, such that previous exposure to hypoxia can change our responses to future hypoxic exposure, or it can change our behavior even after a hypoxic stimulus has been removed. We call this plasticity experience-dependent effects. Intermittent hypoxia, or hypoxia presented in a repeated on-off way, can cause experience-dependent effects. This intermittent hypoxia is particularly important because a clinical population of people with sleep apnea experience this throughout the night. People with sleep apnea periodically stop breathing during sleep, and during these periods they become hypoxic. Because much of the work characterizing experience-dependent effects resulting from intermittent hypoxia has been done in animal models, and these models normally utilize 5-minute on-off bouts of hypoxia, the aim of this study was to investigate the respiratory responses to two different patterns of intermittent hypoxia. We wanted to look at 5-minute bouts to compare to animal work, and then we also wanted to look at 90-second bouts to make the bout a little bit shorter, something more like what is experienced by people with sleep apnea. To do this, we had participants complete both protocols, and we used an end-tidal gas forcing system to control the partial pressure of the gases that participants were breathing out. As illustrated in Figure 1, we took participants through 5 cycles of hypoxia, where we dropped their end-tidal oxygen, shown in black, to 45 torr. This in turn lowered participants' oxygen saturation, shown in white, into the 80s. Both of these measures are normally around 100. The last important thing to note is that the end-tidal CO2, shown in gray, was held stable at 40 torr. There are many different experience-dependent effects, and for this study we focused on post-hypoxic frequency decline, progressive augmentation, and long-term facilitation. After removal of a hypoxic stimulus, post-hypoxic frequency decline occurs if the respiratory frequency or breathing rate becomes lower than it was during baseline. For post-hypoxic frequency decline to be present, respiratory frequency in all of the between bout segments and the washout period would have been significantly lower than the respiratory frequency during baseline measures. As seen in Figure 2, none of these segments had significantly lower respiratory frequency than baseline. Thus, we did not observe this experience-dependent effect in either protocol. Progressive augmentation is an increase in the magnitude of the hypoxic ventilatory response in each subsequent bout of hypoxia. For progressive augmentation to be present, ventilation during the final bout of hypoxia should be higher than the ventilation during the initial bout of hypoxia. Looking at Figure 3, this was not observed in either protocol, thus we did not observe progressive augmentation. Lastly, long-term facilitation is a sustained increase in ventilation that may last for hours following removal of a hypoxic stimulus. For long-term facilitation to be present, the washout period ventilation should be greater than the baseline ventilation. Looking at Figure 4, Panel A and B, this is the case for both protocols. Looking at Panel C, we compared the long-term facilitation magnitude between the 5-minute and the 90-second protocols and found that there was no significant difference between the two. Looking at all these experience-dependent effects, long-term facilitation was the only one that we reported in this data set. This highlights the importance of using human models as well as animal models because not everything reported in animals will be true of humans. While this particular work didn't report any meaningful differences between the experience-dependent effects in the longer versus the shorter duration intermittent hypoxia, it doesn't mean that there aren't any differences. And shorter duration intermittent hypoxia is still very important to continue studying as it better relates to people with sleep apnea. Since this work isolated the hypoxic stimuli that is present when breathing stops, future work should also look at the compounding stimuli present when breathing stops, as when you stop breathing, carbon dioxide also starts to accumulate, and this may change the overall physiological response. Thank you for listening. I just wanted to acknowledge all participants and co-authors for their contributions to this work.